In this video, we learn about the applications of electrolysis. There are many technical and industrial applications of electrolysis. Out of these, three are as follows. The first one we have extraction of metals, that is called as electrometallurgy. Then second is electrolytic refining of metals, that is electro refining, and then electroplating. Now let's talk about electrometallurgy. First of all, it is simple, extracting the metals by the process of electrolysis. From where we are extracting? Obviously, we are extracting them from their ores, which we found below or inside the Earth's crust. So metals like sodium, potassium, calcium, magnesium, and aluminum, they are higher up in the activity series. So they are obviously highly reactive metals. They are being extracted from their ores by this process, which is called as electrolysis. We know that they are metals which are extracted by electrolysis by their fused salts. So these all top metals that are actually what? These are highly reactive metals. They are being extracted by electrolysis from their fused salt or from their ores which are present below the or inside the Earth's crust. Then these elements basically obtained by simply reduction of their salts by reducing agents like carbon, hydrogen, and carbon monoxide, as they are less reactive in nature. Then oxides of mercury and silver can easily be decomposed by heating to give us metals like HgO. On heating will give us Hg plus half O2. Then for gold and platinum, these metals occur even in native state, so no as such chemical reaction for them. Alkaline metals and alkali metals and alkaline earth metals means first and second group metals or elements are normally obtained by the electrolysis of their molten chloride. For sodium, like sodium chloride, which has to be in molten state. Magnesium, we have magnesium chloride has to be in the molten state. Then we can talk about potassium chloride, calcium chloride as well. So we obtained them by the electrolysis of their molten chloride. For example, we have magnesium, which is obtained by molten chloride or molten magnesium chloride electrolysis, and magnesium will get obtained at the cathode. We know that MgCl2 is the formula. Mg positive, what will do? Obviously, it will accept 2 electron and will become Mg, which is solid. So aluminum is obtained by the process of molten alumina, which is Al2O3 aluminum oxide, obtained after the purification of bauxite ore, which is the actual ore of aluminum. Then let's talk about electrolytic refining of metals. Now the metal which obtained after extraction from its ore, still it contains some of the impurities which, if not be removed, it will definitely affect the use of metal. So its properties will get changed due to the impurities. Obviously, removal of these impurities is simply called as the purification of metal or electrolytic refining of the metal. Most of the metals are refined by the process which is called as electrolytic refining or electro refining. For example, we have electrolytic refining of copper. What we need is a solution of electrolyte, which is copper sulfate, to which a small quantity of sulfuric acid has been added. At cathode, we have thin strips of pure copper. At anode, we have thick slabs of impure copper. So let's have a look on the complete setup. Here, this is basically the thin one, which is what? Which is simply pure copper cathode. And then we have thick one, which is impure copper anode. So impure is basically anode and pure is cathode. Okay. What we have to do is simply pass the current. Where? In this solution, which is of copper sulfate. This solution is of copper sulfate solution. So what we have to do, we pass the current through it. Impure copper, that is at anode, what is going to happen? Obviously, oxidation will take place. So at impure copper will lose 2 electrons and it will go into the solution. So impure copper, which is thick, it is made up of Cu. It will lose 2 electron and what it will become? It will become Cu2 positive and it will go inside the solution. Now these 2 electron will go where? They will simply go at the cathode. So the copper 2 positive ions then travels towards the cathode and get deposited over the thin strip of pure copper by gaining 2 electrons. Now these 2 electrons will get gained by what? Obviously by at the copper cathode. The reaction is going to be simple. At anode, copper is being oxidized. At cathode, copper is being reduced. The impure slabs of copper get progressively dissolved. Impure slabs means anode is progressively being dissolved. Why? Because obviously the amount of copper now will go into the solution as copper to positive ions. So it will become thinner and thinner, whereas thins of pure copper become thicker and thicker due to the deposition of copper. The solution, the soluble impurities of iron, lead, etc. remain dissolved in solution, whereas the insoluble impurities of silver and gold fall off the anode and form a deposit below the anode, which we are able to see that this is anode mud or slim. This deposit is called as anode mud or slim, which is of silver and gold. I hope it is clear to you. Thank you.